All right, here on the first page of your handout, we need a couple of definitions because you need to understand the words I'm going to be using. All right? A rational expression is an algebraic fraction whose numerator and denominator are polynomials. All right, that doesn't help much if you don't know what a polynomial is. A polynomial is an algebraic expression made up of one or more terms. So in other words, there are going to be variables in either the numerator or the denominator or both. Since division by zero is undefined, the polynomial in the denominator cannot be zero. So the first thing we're going to talk about is this. When you see something like this, rational expression, the denominator cannot be zero. We don't care if the numerator is zero or not, but the denominator cannot be zero. So that means if you set the denominator equal to zero and solve it, r can never equal 6 or negative 6. Because if r equals 6 or negative 6, your denominator equals 0, and that means you're trying to divide by 0, and that's impossible. So our book that I got these from call these excluded values. Okay? So 6 and negative 6 would be excluded values. R cannot equal those, or it gives us an expression that's undefined. So that's what we're going to look at first. Now look, that can be really hard or really easy, just depending upon what the denominator is. Like here in this next example, n squared plus 4n minus 5. All right? Set that, and then they put an n and an x in their equation. They messed up there. Set that equal to 0, and then you can either solve it using the quadratic formula, or you can solve it, this one's factorable, you can solve it by factoring, and therefore the excluded values for n are 1 and negative 5. Okay? All right, so let's do this one together. So at the bottom of your first page here, the directions say state the excluded values for each rational expression. First thing to remember is that's based solely on the denominator. The numerator has nothing to do with excluded values. And by nothing, I mean nothing. So it's the denominator that you set equal to 0. Write that down. So x squared minus 81 equals 0. Now, we can solve that with the quadratic formula, or this one's a lot easier to solve by factoring. Now, I know factoring's not y'all's favorite thing, but that's a difference of 2 squares. The square root of x squared is x. The square root of 81 is 9. That's x plus 9 times x minus 9 equals 0. Then we use our zero product property. X plus 9 equals 0, or x minus 9 equals 0. So our two excluded values are negative 9 and positive 9. If x equals negative 9, that expression is undefined. Or if x equals positive 9, that expression is undefined. What makes it undefined? The attempt at dividing by 0. That's what makes the expression undefined. Let's look at the next one. Again, the numerator does not give you excluded values. It's just the denominator. It doesn't matter if the numerator equals 0. That's fine. It's the denominator. So we said a squared plus 6a plus 8 equals 0. Again, you can use the formula, but this one's factorable. Factors of 8 that have a sum of 6. Well, the factors of 8 that have a sum of 6 are 2 and 4. So our factorization is a plus 2 times a plus 4. Then we use our zero product property to get a plus 2 equals 0 or a plus 4 equals 0, and then we solve each one of those. And we get a equals negative 2 or a equals negative 4. So the excluded values are negative 2 and negative 4. Any questions? All right. And look, it could be easier, right? The denominator could be something like x plus 5. That's easy to solve. That's easy to set equal to 0 and solve. So that can be a little bit easier than this. I mean, they could make it harder, but this is typical. Okay? You're going to have to be able to do some factoring and remember how to solve by factoring. All right, page 2. A rational expression is in simplest form when the numerator and denominator have no common factors except 1. That's the same thing as a fraction. Okay? For instance, if we have 6 eighths, 6 and 8 have a common factor besides 1. They have a common factor of 2. So we would divide 6 by 2, and then we would divide 8 by 2, and that's how we put the fraction in simplest form. We call it reducing, but that's simplest form. 3 and 4 have no common factors except 1. So we're going to have to do the same kind of thing with these rational expressions. We're going to have to find a common factor for the numerator and denominator and divide it out and get rid of it. That's how we put rational expressions in simplest form. Okay? So we're going to factor the numerator, factor the denominator, divide out common factors. That's what's going to happen. All right, let's look at this example here that would be like a standardized test question. Which expression is equivalent to, and then they've already got that. I don't even know what form I would call that. It's partially factored, okay? It's not all factored out, but it's partially factored. And look what they're going to do with this. Let's just follow theirs. It says, step 1, I'm right here, factor the numerator and denominator using their greatest common factor. So for the numerator, they're saying, all right, I've got an x to the 2nd and an x to the 5th. That's really an x to the 7th altogether. So look how they wrote it. They wrote that as a 3x to the 6th times a negative 4x. So you've still got 7 factors of x. They just juggled them around, which I'm not a big fan of, but that's what they did. And then in the bottom, that 9x to the 6th, they rewrote that as 3x to the 6th times 3. Why did they do that? Well, so that they could say 3x to the 6th divided by itself is 1. So multiplying by 1 doesn't change the value of anything. So in effect, all that becomes a 1, meaning you're left with negative 4x over 3. Now, they wrote it like this. I would have written negative 4x over 3. Okay? All right. That's probably the way I would have approached this problem. All right. If I was working this by myself and not trying to follow somebody else's example, the numerator, I would multiply the negative 3 times the 4 and call that a negative 12. And I would then go x to the 2nd times x to the 5th and make that x to the 7th over 9x to the 6th. And then I'd do it this way, okay? The numbers, I would reduce that the way I always reduce a fraction. I'd think negative divided by positive is negative. Then I'd think, all right, what can I divide out of a 12 and a 9? Divide out of 3. 12 divided by 3 is 4. 9 divided by 3 is 3. I would have done that. Then I'm going to look at the x's. And I'm going to say, all right, I've got an x to the 7th and an x to the 6th. I can divide x to the 6th into both of those, can't I? X to the 6th divided by x to the 6th is 1, so in effect it's gone. And then x to the 7th divided by x to the 6th is just an x, isn't it? So that's probably the way I would go about this. All right, you can think of it that way. When you're dividing factors with the same base, subtract the exponents. So 7 minus 6 is 1, so that's an x to the 1. Exactly. Then since the 7 was in the top, the answer stays in the top. Now, and that's one of those things, good news, bad news. Good news, you guys know enough math now, and have for a couple years, to do things more than one way. Bad news is, you guys know enough math now, and have for a couple of years, to do things more than one way. Yeah. And you know, and that's one of those things where we just need to realize that that is equivalent to that. Make sense? Any questions? All right. Page 3. Which expression is equivalent to 16c squared b to the fourth divided by 8c cubed b? And I like this one a little bit better than the other one because it is already multiplied out for us. Okay? I think the other one was a little harder because it wasn't. Now, I'm going to do the same thing I did in my second method just a second ago. I'm first going to deal with the numbers, then I'll deal with the C's, then I'll deal with the B's. All right? So, here we go. 16 over 8. Well, 16 divided by 8 is 2. Now, that 2 would either go in front, or would it go in the numerator or the denominator? Numerator, because that's where the bigger number is, the 16. Okay? So, 2 in the numerator. All right? Now, c squared over c cubed. Let's do what Yasmin said. Let's subtract the exponents. 3 minus 2 is 1. So we got a c to the 1. In the top or in the bottom? In the bottom, because that's where the bigger number was. So we'll end up with a c to the in the bottom. All right? And then b to the fourth over b. What's that simplify to? B to the third, where? On the top. Now, you see how I kind of marked things out there and wrote them in? Some of you can do that and make sense. Some folks that doesn't make any sense to. So if what I did marking things out makes sense, fine. If not, don't do it. Ooh, and I shouldn't have said marking things out. So I wasn't just randomly marking things out. I was dividing. Okay, I was dividing. So I've got a 2 in the top, and I've got a b cubed in the top, and I've got a c in the bottom. So 2b cubed over c is our answer, so we would choose F. Okay? Now, the type of problem we're going to spend most of our time on is like example 4 here. We're going to simplify, and we're going to state the excluded values. So we're going to do both things in one problem. Let's simplify. Now, on this one, the factoring is a little different, isn't it? Because here we have a binomial on the top and a trinomial on the bottom. So follow along with me here on example 4. 2r plus 18, it has a greatest common factor of 2. So you turn that into 2 times r plus 9. And then r squared plus 8r minus 9, we're looking for factors of 9 that have, and 9's negative, so we're looking for factors of negative 9 that have a sum of 8. And that would be a positive 9 and a negative 1. And then look how cool this is. And look, let's face it, they're making up problems so that this happens. See how you now have a factor of r plus 9 in the numerator and in the denominator? And isn't r plus 9 divided by r plus 9 1? So that's what they're doing here on this step. They're dividing r plus 9 by r plus 9 and getting 1. So in the numerator, 2 times 1 is 2. In the denominator, 1 times r minus 1 is r minus 1. We're going to do a bunch just like that. So are there any questions on that one? And then they find the excluded values the same way we've been doing it. I would start right there. Since I've already got the denominator factored, when I start solving to get excluded values, I wouldn't write r squared plus 8r minus 9 equals 0, because I've already got it factored. So I would write down r plus 9 times r minus 1 equals 0. Solve that. Those are your excluded values. All right, let's do one together. Bottom of page 3, 4a. First, let's simplify. The numerator is n plus 3. Well, there aren't any factors to factor out of n plus 3. But your denominator is n squared plus 10n plus 21. So we need factors of 21 that have a sum of 10. Factors of 21 that have a sum of 10. 7 and 3. So we'll write that as n plus 7 times n plus 3. Now, when you get stuck on factoring, and you will, guess this. Since the only factor in the top is n plus 3, go ahead and guess n plus 3 is one of your binomials and then figure out what goes with it to make it work. Now, will guessing always work? When you're stuck, that's something to do, though. When you're stuck. Make sense? All right. And then what are we going to do next? Well, n plus 3 divided by n plus 3 gives you a 1 both places. So what's left in our numerator? Just 1. What's left in our denominator? N plus 7. All right. Now, we also have to state the excluded values. The excluded values come from when the denominator equals 0. I've already got the denominator factored, so I'm simply going to write n plus 7 times n plus 3 equals 0. And what are my two excluded values? Exactly. Negative 7, negative 3. All right. I want you to do 4b by yourself. 4b by yourself. All right, most of you seem to be doing pretty well with this. Back to the top, you're looking for factors of negative 10 that have a sum of 9. So a positive 10 and a negative 1 should do that. In the bottom, the only thing you can do to the bottom is factor out a greatest common factor of 2. And that seemed to give you more trouble than the top did. I think you were expecting it to be harder, I think. So are you guys with me on this factorization? All right. What can we divide out? And by the way, we might get to this step and not be able to divide anything out. But don't count on that happening very often. That kind of defeats the purpose of the problem if nothing divides out. Okay? So what factor is in the top and in the bottom? The y plus 10. Now, notice they're not written, this y plus 10 is not written right above that. That doesn't matter. Okay? Any factor in the numerator can be divided by any factor in the denominator as long as it's the same factor both places. Okay? So, y plus 10 divided by y plus 10 is a 1. Meaning, in the numerator, we're left with 1 times y minus 1. Well, 1 times y minus 1 is y minus 1. In the bottom, we're left with 2 times 1, which is just 2. So, that's our simplified expression. Okay? All right. Now we find the excluded values. Set your denominator to y plus 20, or better yet, the factored form of your denominator, 2 times the quantity y plus 10 equal to 0. And so then we get y equals negative 10. And notice, and this is a little weird, but notice to find the excluded values, we did not use the simplified denominator. We used the denominator before it's simplified. Because let's face it, once we've simplified this, 2 is never going to equal 0. Once we've simplified it, any value for y is okay. But it wasn't at the beginning. Okay? Same thing over here. Once we've simplified the 1 over, to get 1 over n plus 7, negative 7 is the only excluded value at that point, isn't it? N can equal negative 3 then, but it couldn't for the original problem. So make sure you're doing excluded values that way.